Hello friends, this is Priyanka. Today we are going to solve a problem on Proell governor where the flyballs are rotating with an inclined position with vertical line. In this video we are going to draw diagram as per given data. Now first I will read what is the given problem. The following particulars refers to a Proell governor with open arms. Length of our arms is equal to 200 mm. Distance of pivot of arms from the axis of rotation 40 mm. Length of extension of lower arm to which each ball is attached 100 mm. Mass of each ball 6 kg. Mass of central load 150 kg. If the radius of rotation of the balls is 180 mm when the arms are inclined at an angle of 40 degree to the axis of rotation, find equilibrium speed for the above configuration. So this was the given question. Let us first understand how to draw the diagram as per given data. Now if we observe the question, it is given that the length of arms 200 mm. These arms are pivoted at a distance of 40 mm from the axis of rotation and the angle made by arms with vertical line is equal to 40 degree. So these are the basic lines we have to consider while drawing the diagram. So we have to first draw spindle axis, and that is known as the axis of rotation in the form of dash and dot. So here is one vertical line in the form of dash and dot which is known as the axis of rotation. Now we have to take the fixed points, that is the pivoted points, at a distance of 40 mm as per the given data. So we will select one particular point, that is point Q, on this axis of rotation, and we will take here one horizontal distance of 40 mm. And this is the point P, that is the pivoted point of the arm. Then what is the length of arm is given? So length of arm is given, that is equal to 200 mm, and this arm is inclined at an angle of 40 degree. So from this point P, again we have to draw one vertical line passing through this point P, and at an inclination of 40 degree we have to draw here this arm PF which is equal to 200 mm. Now again at the base point we will select one particular point, that is point K, and here is also we have to maintain the distance of 40 mm, and then lower arm, that is also equal to 200 mm. So from this point F we have to again draw one length arm, that is equal to 200 mm, and here is the point, that is the point D. So this arm DF which is equal to 200 mm, the angle made by this lower arm with this vertical line is also equal to 40 degree. So we can say that this is the angle alpha and this is the angle beta which is equal to 40 degree. Then here this point D is the pivoted point for the lower arm. So this distance dk which is equal to pq which is equal to 40 mm. Now it is given that the flyballs are rotating with inclination. So arm of this flyball is nothing but the extension of this lower arm. So here is the point F. We will first draw one vertical line in the form of dash from passing through this point F, and we have to show some inclination, and this arm BF is the inclined arm and the length of this arm is given 100 mm, where B is the center of flyball. So here we have to draw this flyball. Then mass of the flyball is also mentioned, that is 6 kg. So due to mass there is the weight of the flyball, and we know that weight always acts in vertically downward direction passing through the center of flyball. So here I have shown this weight mg that will act in vertically downward direction. There is the central load, that is capital M, which is equal to 150 kg, and the central load is attached to the sleeve. So we have to show that. But in this question we will refer here only half part of the governor. So we will refer here only the half central weight. That is, what is the weight? Because mass is equal to 150 kilogram, weight is equal to m into g, that is capital M into g, and that will act in vertically downward direction passing through this pivoted point. That is, we have to show here, this is the point D, we have to show half central load. That is, half load means this total load is 150 into 9.81, but we have to take this capital M G by 2, and we have to show the downward direction passing through this point D. Now we have to make some constructions. We will first plot the instantaneous center for this diagram. So how to plot? So for that we have to extend this arm PF. So in the same inclination we have to extend here this arm PF. And again here we have to draw one horizontal line passing through this point D. So instead of saying horizontal line, I will say that we have to draw one perpendicular line with the axis of rotation passing through this point D. So this spindle axis is the vertical line. So we have to draw here one horizontal line passing through the point D, and we will get here the instantaneous center, that is I. So this is the point I. Now if I draw one vertical line passing through this point F, so here is the point of intersection to this length di, so I will say this point will be N. And again I will extend this weight mg, which will act in vertically downward direction. So again I will, if I extend this, and here is also the point of intersection on this length di, I will say that this is the point M. And again from this point F I will draw one horizontal line backward, and the point of intersection with this total length BM is nothing but here is the point Z. Now again we have to make one construction. So passing through this point F we have to draw one horizontal line. Then there is the point of intersection with this line joining these pivoted points PD. So this is the point of intersection is point H, and for this horizontal line there is again the point of intersection with this axis of rotation, and this point will be point G. Now if we observe this diagram, we can say that here this arm PF, which is equal to FD, then these two angles are also same, that is angle made by these two arms with this vertical line are also same. So we can say that here point H will be the middle point of this total vertical length PD. In the same way, this point G will also the middle point or midpoint for this total vertical line QK. So this is by observation, because as per the given condition, if these two lengths are same and the angle made by these two lines with vertical line are also same, so the line passing through this point F is also the midpoint for this vertical line. If we observe this system when it is working, then these flyballs are rotating about this vertical spindle axis. Then here the centrifugal force that is acting passing through the center of these flyballs in radially outward direction. So we have to show here centrifugal force. At the same time, because of the weight of the flyball, there is the weight mg which will act in vertically downward direction, and due to central load we are going to consider only half portion of the governor. Central load passing through this point D is mg by 2. Now we have to find out what is the equilibrium speed. So we will consider n is the equilibrium speed that we have to find out. Now we will take the moment about the instantaneous center I. So how to take the moment? So we know that moment, that is force multiplied by the perpendicular distance. So with the help of compass we will understand how to take the moment. Now this is the instantaneous center. Here is the FC that will act in radially outward direction, because here is the axis of rotation. So if I take I as a center and move the compass in the direction of FC, then there is the direction. I will show here, this is the direction. So this direction is the anti-clockwise direction. So we have to take this FC multiplied by perpendicular distance. So what is the perpendicular distance from this I? That is B to M. So this I will say that FC multiplied by BM. Now next force is due to this weight mg. So again, if I take I as a center and move the compass in the direction of this mg, that is in the downward direction. So here is the direction. So here is the direction, that is in the clockwise direction. That is opposite to this FC. So I will take this moment on the opposite side of the equation. That is this FC multiplied by BM is equal to this mg multiplied by perpendicular distance. So what is the perpendicular distance? That is this IM. Then here is the central load. So again, if I take I as a center and move the compass in the direction of this mg by 2, then again there is the same direction, that is clockwise direction. So on the same side of this mg I will add this. So how to take the moment? That is this mg by 2 multiplied by perpendicular distance. So this ID. So here plus mg by 2 into ID. So this is the equation when we take the moment about I, and this is the moment we are taking considering the equilibrium of the system. And when we solve this equation, then we will get what is the equilibrium speed n. So before that we have to first find out what is the distance B to M, then what is distance I to M, and what is the distance I to D. So how to find out? So we know that if we observe this diagram, BM is equal to this BJ plus JM. So we will first find out what is this distance J. So we know that this point G is the central point. So we can say that this QG, which is equal to GK, or we can also say that this PH, which is equal to HD. Now this HD, which is equal to JM. So for that, for this value of Jm, we will first find out what is the distance of PH. So from this triangle PFH, we can find out the distance PH, because this length PF is known and this angle is also known. So what is this value of PH? So PH is equal to PF cos of 40. So when we solve this, that is 200 into 0.766, we will get 153.2 millimeter. So we can say that this 153.2 millimeter, that this distance PH, which is equal to HD and which is equal to JM. So this JM, that is equal to 153.2. Then we will find out FH. So what is this distance FH? So again we will consider this triangle PFH. So here this side is opposite to angle 40 degrees. So we can say that PF sine of 40. So PF is 200 into 0.643, that is 128.6 millimeter. So this is the distance of FH. Then what is the distance JF? So if we observe here, JF is equal to this total distance J to G minus this distance FH and minus HG. So if we observe the question, it is given that the radius of rotation of the fly ball, that is equal to 180 millimeter. So radius of rotation of fly ball, that means the distance from the center of this fly ball to the axis of rotation is equal to 180 millimeter, and that is mentioned here. So this R is nothing but distance from J to G. So I will show here in the diagram. So this horizontal distance we have to mention. So this is important. What is the meaning of radius of rotation? That means distance from center of fly ball to this axis of rotation. Now we have to find out JF. So how to find out this JF? So JF is equal to this total distance JG minus FH minus FG. So FH that we have calculated here, that is 128.6. So we will take here. So JG is nothing but 180 minus 128.6 and minus HG. So this HG is equal to PQ, which is equal to 40. So what is this distance ZF? That is 11.4 millimeter. So this ZF is equal to 11.4 millimeter. Now we will move for the next. That is, we will find out what is the distance B to J. So how to find out this distance B to J? So we will refer here the triangle BJF. So for this distance BJ, we will say that this is right angle triangle. So under root of BF square minus JF square, because these are the other two sides. So BF square minus JF square. So BF is nothing but, it is given that 100 millimeter, that is mentioned in the question, and JF we have calculated here 11.4. So under root of 100 square minus 11.4 square, which is equal to 99.4 millimeter. So in this way, this BJ is getting calculated. Then this BJM is nothing but HD, and it is nothing but PH. So PH is also getting calculated. So what is the value of BM? That is 99.4 plus 153.2, that is equal to 252.6 millimeter. So this one side, that is this BM is getting calculated. Now we will move for calculation of IM. So here is the I to M. So how we can define this IM? So IM is equal to this IN minus NM. Now if we observe this diagram, so this MN, which is equal to JF. So this JF we can take as it is, as a NM. And what about this IN? Now we have to again observe this diagram. Now here this PF is getting extended. So this link PF is getting extended up to point I. Here the angle made by PF with this vertical line is 40 degree. If I draw one vertical line passing through this point F, because here point F is the starting point for this length Fi. So here is also same angle, because these two are the parallel lines and this is the common line. So I will say that this is the 40 degree. Now if we observe here, this is the triangle PFH and here is the triangle FIN. So in these two triangles, this side FN, which is equal to PH, because here H is the middle point. So we know that this PH, which is equal to HD, which is equal to FN. That means these two sides are same. And here the angle made by the second side is also same, that is 40 degree. So we can say that this IN is nothing but which is equal to FH. And this FH is already getting calculated. Here is FH. So this is 128.6. That is getting calculated. And this FH, which is equal to IN. So we can easily take here IN is equal to 128.6 minus NM, that is equal to JF, which is equal to 11.4 and which is equal to 117.2 millimeter. So in this way, this second side, that is IM, is also getting calculated. Now next is ID. So I to D. How to measure this distance I to D? So if we observe here, that is ID is equal to IN plus ND. Now IN is nothing but we have calculated I to N, that is equal to FH, which is equal to 128.6. And this ND, if we observe this diagram, here is the vertical line. So this distance H and D, these are the collinear points. Then here is also vertical line passing through the point F, that is this F and N are also collinear points. So we can say that this FH is nothing but that is equal to ND. So this ND, which is equal to FH, this IN, which is equal to FH. So we can say that ID is equal to IN plus ND. So IN is 128.6, ND is also equal to 128.6, which is equal to 257.2 millimeter. So this length is also getting calculated. Now we will put values in the equation and we will find out what is the equilibrium speed N. So this FC multiplied by BM, that is 252.6, which is equal to small m, that is 6 multiplied by 9.81 into 117.2, plus capital M, that is 150 into 9.81 by 2 into 257.2. So here Fc is only one unknown term, so Fc is 776.4 Newton. Now what is this centrifugal force? Centrifugal force is nothing but mr omega square. So this centrifugal force is acting through the center of the flyball. So m is mass of the flyball, r is the radius of rotation of flyballs, that is 180 millimeters. So here we have to take this in meter, that is 0.18 meter, and omega. So omega is the angular velocity. So we can write this in term of n, that is omega is equal to 2 pi n by 60. So here omega square is there. So we will refer 2 pi n by 60 bracket square, which is equal to 776.4. So again we will simplify this. So 6 into 0.18 into 4 pi square by 3600 into n square, which is equal to 776.4. So n square is equal to 64,700. So if I take the square root on both the sides, we will get the answer n is equal to 254 rpm, and this is the answer.